Ever look at like two lamps on your desk and think, huh, they both kind of just light things up, right? Like they look
Mhm.
the same, but what if there's a whole world of difference we just don't see?
Exactly. Remember back in school? Prisms splitting sunlight into a rainbow.
Yeah.
A spectroscope does something similar, but instead of the shape, it uses a special surface to spread light out into its colors, like wavelengths. And that separation, it tells us what each light source is really made of, even if they look the same to us.
So it's not just pretty colors, right? This matters. Like up in space, astronomers use this to figure out what stars are made of, even how old distant galaxies are, all from the light they send us.
It's true. And by carefully looking at how bright each of those colors is in the light, we can even tell things like the temperature of a star or how fast it's moving away from us. It's like a whole story written in light.
Okay, so for this deep dive, we're going to build our own spectroscope. A simple one, using stuff you probably have around the house.
It's really cool because you actually get to see this science in action, not just read about it.
Absolutely. We're going to follow along with a YouTube video from the Cambridge University Astronomy channel. It's their Build Your Own Spectroscope activity. Super fun.
So yeah, we'll break it all down, how to build it, and more importantly, what to look for once you've got it. Get ready for some serious aha moments about the light all around us.
First things first, what do we need to gather up to build this thing?
You might be surprised, it's really basic stuff.
Like what? Give us the rundown.
Okay, so you'll need some cardboard, like an old cereal box is perfect.
Got it.
Then a cardboard tube, like from a toilet paper roll. And here's the cool part, a DVD or a CD.
Oh, cool. I haven't seen one of those in ages.
Right. Then some black masking tape, regular tape, a ruler, scissors, and a paper cutting knife. And if any younger listeners are joining us, make sure you have an adult help with the knife.
Definitely. Safety first. What else?
Oh, and a pencil for marking. Pretty basic stuff, right?
Yeah, totally doable. All right, so we've got our supplies. What's the first step?
First, we need to make what's called a diffraction grating. That's what actually splits the light into colors. And the video says starting with a DVD is easier. It often gives a clearer result, too.
Okay, so what do we do with the DVD?
So DVDs have these two thin layers stuck together. You want to carefully make a little cut at the edge, then kind of gently peel those layers apart using your fingernails,
Mm-hmm.
like separating two pieces of film.
Okay, got it.
And the layer we want is the bottom one. That's where the tiny grooves are. That's the diffraction grating. The shiny top layer, we can toss that.
Oh, cool. So all the magic happens on the bottom.
Yep. You might even see a little rainbow on it already.
Whoa, really?
Yeah, those tiny grooves, they're what diffract the light. It's kind of like if you imagine waves in a pond hitting a wall with small openings. They spread out in a pattern.
I see.
Light does the same thing. And different colors, they have different wavelengths, so they bend at slightly different angles when they hit those grooves. That's how they separate out into the spectrum.
Wow, that's so cool. And how much of the DVD do we need?
Just cut out a little section about 2.5 centimeters across from the edge of that bottom layer.
Got it.
And one DVD can actually give you a bunch of these gratings, like maybe 6 or even more. So if you're doing this with friends, you can all make one from the same DVD.
That's awesome.
Right. But now, what if you only have CDs, not DVDs? Don't worry, you can still make a grating. It's just a little different.
Oh, okay. How so?
So CDs don't have those easily peeled layers. We need to be a bit more creative to remove that top shiny silver layer.
Okay. Create a how.
You take your paper cutting knife and carefully make a small scratch on the surface, right near the edge.
Got it. What next?
Then get some tape, stick it firmly over that scratch, and slowly peel it off. With any luck, the tape will pull off a little bit of the silver coating with it.
Oh, interesting.
Yeah, and you might have to repeat this a few times, trying different spots, until you get a decent clear section where that silver used to be. That clear part, that's your diffraction grating.
So we're basically making our own little window on the CD.
Exactly.
Yeah.
It might take a bit of patience, but it works. And actually, even though it's a bit trickier, the video actually suggests starting with a CD grating for your first spectroscope.
Oh, what's that?
Turns out, the angle you view the spectrum through is smaller with a CD grating. And that makes it easier to see the whole thing at once and even take pictures of it later on.
Huh, who knew? So a little extra effort at the start makes it easier to use later. That's a good tip.
Definitely.
Huh.
Okay, now that we've got our grating, let's build the body of the spectroscope. Back to our toilet paper roll and cardboard.
All right, crafting time.
Exactly. Take that toilet paper roll and trace circles on your cardboard, 2 of them. We need one for each end of the tube,
Gotcha.
and then just cut them out. The guy in the video, he even had a little trouble cutting a perfect circle.
Really?
Yeah, it can be a bit fiddly, But don't worry, it doesn't have to be perfect as long as it covers the end of the tube. Now the next step, this is important. We need to make the inside of the tube as dark as possible,
Oh, why is that?
so it doesn't reflect any extra light and mess up our spectrum. We only want the light coming through the slit and hitting the grating to be what we see.
Makes sense. So how do we make it dark?
Black masking tape works great.
Yeah.
Just stick strips of it on the inside, overlapping a bit until the whole tube is blacked out.
Okay, easy enough?
Yep. They also say you could use black paint or even rub charcoal on the inside if you don't have tape.
Yeah.
Anything to absorb the light.
All right, cool. So we've got our dark tube. What's next?
Now we make the slit and the window for the grating.
Okay, two more important parts.
Yep, let's start with the slit. The video really emphasizes how a thin, precise slit will give you a much clearer spectrum.
Makes sense. So this is where we got to be careful.
Exactly. We want a very narrow beam of light to enter the spectroscope. And the best way is to use your ruler and that paper cutting knife.
Okay, careful, careful.
Right, so you make a careful cut along the ruler, then shift the ruler just a tiny bit and cut again. You repeat this like several times along the same line until you can gently remove a very thin strip of cardboard from one of your circles.
So we're basically slicing off a super thin line of cardboard.
Yep, that's your slit. It might take a little practice to get it perfect, but it's worth it. Now, for the window, for the grating, it's much simpler.
Okay, good.
You just take your other circle and draw a square in the middle, leave some space around the edges so it doesn't tear, and then carefully cut that square out.
So now one circle has a tiny slit and the other a square window. What happens next?
Now we add the diffraction grating. The video says to start with the CD one.
Okay, CD it is.
Before you attach it, it's a good idea to trim the grating so it fits neatly inside the window and doesn't stick out. Keeps it safe from scratches.
Makes sense. We don't want to ruin it after all that work.
Exactly. Once it's trimmed, just use some tape to stick it to the inside of the circle, covering the whole window.
All right, almost there. We've got our slit and our window with the grating. How do we put it all together?
So first, take the circle with the slit and attach it to one end of the tube using tape. It doesn't matter which way the slit is facing, as long as it's not blocked.
Okay, got it.
Now this next bit is super important. We need to align the grating window properly at the other end. This is what lets you actually see the spectrum.
Okay, I'm all ears.
So point the slit end of the tube at a light source.
Got it.
Now, while holding the grating window near the other end, look through the grating towards the slit. You need to rotate that window until you see a clear rainbow spectrum.
So like a band of colors.
Yeah, a wide strip. And it'll appear perpendicular to the slit. So if your slit is vertical, the rainbow will be horizontal and vice versa.
Oh, that's cool. And once I see that, I tape it down.
Exactly. Once you've got that clear spectrum, take the window down securely and bam, your spectroscope is done.
Woohoo, we did it.
The video also suggests taking a minute to clean up any loose tape or anything, just to make it look nice.
Good point. Gotta make it look professional. Now the fun part, what can we actually DO with this thing?
Now you get to go around and look at all sorts of light sources. Point the slit at the light, and you'll see its spectrum through the grating.
Awesome, like a secret decoder for light.
Exactly. Just remember, never point it directly at the sun.
Oh, yeah, right. That's dangerous.
Seriously, it can hurt your eyes really badly, but you can point it at something that's reflecting sunlight, like a white wall.
Got it. Safety first. So what kind of cool stuff did they see in the video?
Oh, they looked at all sorts of things. First, they looked at a computer monitor, like an LCD one. Then they looked at a white LED ceiling lamp. You know, the ones that have different settings?
Yeah, I've got one of those.
They actually showed how the spectrum changed when they switched it from cool white to warm white. You could clearly see more blue in the cool setting.
Wow, so even white light can be different.
Absolutely. And then they compared that ceiling lamp to a little LED desk lamp, both on white setting. Even though they looked the same to our eyes, the spectra were totally different.
That's crazy. You never know without the spectroscope.
Right. Then they went through all the colors on the desk lamp.
Yeah.
Red, blue, green, yellow. It was so cool to see how they mix to make all the different colors.
That's like the basics of how screens work, right? Red, green, and blue make all the other colors.
Exactly. And then, get this, they looked at a street light, a high-pressure sodium one. It had these really beautiful, bright lines of color, like fingerprints for the elements in the light.
Whoa, really?
Yeah. And they said, depending on where you live, you might not see sodium lamps anymore. Lots of places are switching to LEDs for street lights, too.
Huh. I'll have to check mine out.
Yeah, see what kind of spectrum you get. It's like a little science experiment right outside your door.
So cool. I'm definitely building one of these this weekend.
You should. It's really amazing to see this stuff for yourself. And it makes you think, like, what
Hey
other
there,
hidden
science
things are out there
enthusiasts.
that we just
Welcome
don't
back to our
notice?
That's
channel,
a great
where we
point.
explore the
So
wonders
to all
of the
our listeners,
universe.
build a
Today,
spectroscope,
we're diving
explore,
into
and
the
keep an eye out
fascinating
for the
world of light
unexpected.
with our
Who
movie,
knows what you might
Build a
discover.
Simple
Thanks for
Spectroscope,
joining us for this deep
exploring
dive,
the
and until
universe
next
of
time,
light.
keep
Did you
looking
know that you
closely.
can build your own spectroscope at home? It's a simple yet powerful tool that can help you understand the universe of light. By splitting light into its component colors, you can observe the spectrum of light and learn about the different wavelengths and their properties. This movie will guide you through the process of building your own spectroscope, so you can start exploring the universe of light right in your own backyard. We'll also delve into the fascinating world of light and its role in our universe. Build a simple spectroscope, exploring the universe of light. This document serves as a comprehensive guide for constructing a simple spectroscope at home, aimed at fostering curiosity about light and its properties. Asha, the presenter, introduces the significance of spectroscopes in astronomy, from analyzing the sun to distant galaxies. By following this guide, viewers will learn to build their own spectroscope using readily available materials, with an estimated completion time of about an hour. Adult supervision is recommended for younger participants when using sharp tools. Materials gathering to build your spectroscope. Gather the following materials: cardboard, toilet paper, core, DVD or CD disc, black masking tape, sellotape, ruler, scissors, paper, cutting knife, diffraction, grating, DVD. Make a small cut at the edge of a DVD. Split the two layers of the DVD apart using your fingernails. Discard the shiny top layer and retain the bottom layer containing the grooves, the diffraction grating. Cut out a small section around 2.5 centimeters across from the edge of the grating. One DVD can yield about 6 gratings. Preparing the diffraction grating CD. Make a small scratch on the shiny silver coating near the edge of the CD using a paper cutting knife. Firmly stick sellotape onto the scratch area. Slowly peel the tape away from the scratch, removing a chunk of the shiny coating. Repeat the process until a large enough section of the coating is removed to cut out a grating. Note that cutting a CD is harder than cutting a DVD. Constructing the spectroscope body. Trace the shape of the toilet paper cores, opening twice onto the cardboard. Cut out the 2 cardboard circles. Mask the inside of the toilet paper tube to be dark and non-reflective using black masking tape. Alternatively, paint or charcoal pencils can be used. Apply strips of tape lengthwise, trimming and folding the excess around the edges for a neat finish. Creating the slit. Choose one of the cardboard circles to become the slit. Using a ruler and a paper cutting knife, cut a very narrow and precise slit in the center of the circle. Multiple passes with the knife and careful removal of the thin cardboard strip are recommended for a crisp slit, creating the diffraction grating window. Use the other cardboard circle to create the window for the diffraction grating. Sketch a square in the center of the circle, leaving space between the square and the edge. Cut out the sketch square using a paper cutting knife to create a window, attaching the diffraction grating. Trim the prepared CD or DVD diffraction grating to fit within the window of the cardboard circle, ensuring it doesn't extend beyond the edges. Attach the grating to the window using masking tape. Final assembly. Attach the slit cup to one end of the toilet paper tube, using masking tape, ensuring the slit remains unobstructed. Align the diffraction grating window with the slit by pointing the slit towards a light source and looking through the window. Rotate the window until a clear spectrum appears perpendicular to the slit's orientation. Once the correct alignment is achieved, tape the diffraction grating window securely to the other end of the tube. Completing the spectroscope. Using the spectroscope to observe different light sources, point the slit towards the light and look through the diffraction grating window. Caution: never look directly at the sun. Instead, observe sunlight reflected off a surface. Examples of light spectra. Asha demonstrates examples of spectra observed from various light sources, including LCD monitor, cool white LED lamp, warm white LED lamp, color-changing LED lamp showing red, blue, green, yellow, and white light. High-pressure sodium highlights the differences in the spectra of seemingly similar white light sources and the distinct emission lines of the sodium lamp. Viewers are encouraged to explore the light sources around them, take pictures of the spectra, and share their findings. Contact information is provided for sharing pictures for the Science Week website. Asha concludes the tutorial by encouraging viewers to stay curious and continue exploring science. This hands-on activity not only enhances understanding of light, but also promotes creativity and scientific inquiry.